We are still in finding the inverse of a linear transformation, but this time we are going to have a linear transformation from R3 to R3. We can see that because we have here three components of our vector, and the resulting vector after the linear transformation, we also have three entries, 1, 2, and these three entries here. So since this is a linear transformation from R3 to R3, we need to understand that the certain standard matrix we're going to use later is also a 3 by 3 matrix. Why do we use that? Because the process of solving the inverse of a linear transformation starts with identifying the standard matrix of our given linear transformation. After that, we are going to find the possibility of its inverse. The inverse of the standard matrix first. If we could see a standard matrix, which is actually, we could see the inverse of a standard matrix, that automatically mean our linear transformation is also invertible. So after that, of course, if it's not, then the linear transformation is not invertible as well. So we are going to pair it with a certain vector v later, before we could show the final form of our inverse of the linear transformation. So again, let's start with the standard matrix. The standard matrix here, again, is a 3 by 3 matrix. And we are going to have the components x sub 1, x sub 2, and x sub 3 for different columns. So the first column would be the coefficients of x sub 1, second column the coefficients of x sub 2, and the third column would be the coefficients of x sub 3. So the first one here, first entry for the linear transformation is x sub 1. So you have 1 x sub 1, but you don't have x sub 2. You also don't have x sub 3. Next, you have x sub 1 plus x sub 2. So x sub 1, x sub 2, but you don't have x sub 3. And for the third entry, x sub 1 plus x sub 2 plus x sub 3, you have 1, 1, and 1 here. With this is now our standard matrix, and we are going to show the second step, the inverse. Now the inverse, okay, of our standard matrix will not be using a theorem involving determinants from last time, because that is only for a 2 by 2 matrix. What we could do here is this. If we are going to come up, okay, let me repeat that. Okay, we are going to use this process. Going to have an augmented matrix of our matrix A, where we pair it with the identity matrix of a 3 by 3 matrix, and then we are going to manipulate it in such a way that the entry here will become the identity, and the resulting identity, the identity matrix after all the elementary row operations, you will have here your inverse of your A. That's a process for a 3 by 3, finding the inverse of a 3 by 3 matrix. So in this case, it will be a little bit longer, but please bear with me. You have 1, 0, 0, 1, 1, 0, 1, 1, 1. Okay? This will be paired with 1, 0, 0, 0, 1, 0, and then you have here 0, 0, 1. Then we apply here the necessary operations so that this matrix here will become the identity matrix itself. What we could do is to make this 0, okay, and then this 0 as well. So applying negative 1 to row 1 plus row 2 for a new row 2, and negative 1 of row 1 plus row 3 for a new row 3. With this, take note that this operation should also affect this second matrix here, because that should be the inverse of A that we're going to have later. So you have 1, 0, 0, so the top is unchanged. You will have here negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times this is 0, so this is still 1, this is still 0 here. Negative 1 times 1 is negative 1 plus 0 is negative 1. Negative 1 times 0 is 0, so this is still 1, that's still 0 here. In the third row, negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times 0, so this is still 1, this is still 1. Negative 1 times 1 is negative 1 plus 0, negative 1. This is still 0, that's still 1 because the multiplier here are all zeros. Next, let's make this 0. Okay? So you will have to multiply negative 1 to row 2 plus row 3 for a new row 3. So this would mean this is unchanged. Sorry, this is still 1, 0, 0. The second row is also unchanged. The third row will look like this. Negative 1 times 0, 0, this is still 0. Negative 1 times 1 is negative 1 plus 1, 0. Negative 1 times this is 0 plus 1, so this is still 1. Negative 1 times negative 1 is positive 1 plus 1, 0. Negative 1 times 1 is negative 1 plus 0, negative 1. So this is still 1 here. Now that we have reached the identity matrix for a 3 by 3 matrix, this will now be your inverse of A. In short, the inverse is equal to this matrix here. Okay? So you have 1, 0, 0, negative 1, 1, 0, 0, negative 1, and then 1. Okay? That's how we show our inverse for a 3 by 3 matrix using this process. Now with that, we're going to proceed to this step, multiplying the inverse with a certain vector, but that vector is with this components. So you will have here 1, 0, 0, negative 1, 1, 0, 0, negative 1, 1, to be multiplied with x sub 1, x sub 2, x sub 3, the components here. So when you multiply that, you will have these entries. Take note, this is a 3 by 3, 3 by 1, so you're expecting a result which is a 3 by 1 as well. So 1 times x sub 1, x sub 1, 0, x sub 2, 0, x sub 3. Next, negative 1 times x sub 1, so negative x sub 1 plus x sub 2 plus 0, x sub 3. Then 0, x sub 1, negative x sub 2 plus x sub 3. With this will now be part of your inverse, to which what we're looking for. The inverse of our linear transformation will have these 3 entries: x sub 1, negative x sub 1 plus x sub 2, and negative x sub 2 plus x sub 3. This is now the result for the inverse of the given linear transformation. So again, the process involves the coming up of standard matrix, gets an inverse, but in this case we'll be using this. Then after that, if it's invertible, multiply with your vector here, and then to get your inverse of linear transformation. Thank you very much for watching.